This is the equation in vertex form, and the vertex is at 2, 1. Good thinking if you found these two. Now, this one was pretty tough, especially since we had a -3 here. Let's work through it together. Our goal is to get a perfect square so that way we can put this equation in vertex form. So we're going to try and complete the square by adding some amount to our polynomial. I can't quite complete the square yet since I have a factor of -3 in front of the x squared. We want this coefficient to be a 1. This means we can factor a -3 from these two terms, leaving us with -3 times x squared minus 4x. We can quickly check to make sure that if we distribute, we would get back with what we started with. We'd have -3x squared here, and -3 times -4x, which is positive 12x. Now we're ready to complete the square. The b term is -4, so b divided by 2 equals -2, and b divided by 2 squared equals 4. We simply square this number. So we need to add 4 in order to complete the square for this trinomial. But we didn't just add 4 here. We really added -12, 4 times -3. Again, think about distributing this -3 to each of the three terms, and we would wind up with this expression. Now, we can't just go adding numbers to equations and changing them at random. Instead, we need to keep things balanced. If we subtract 12 from an equation, then that means we need to add 12 to the equation as well. This makes the equation balanced. It makes it so that way it's not changed. We know this since -12 and positive 12 sum to 0. So we're just changing what this equation looks like, but it's really the same exact equation. Now that we're here, we're ready to write our perfect square. The perfect square for this trinomial is x minus 2. If we square this amount, we'll get this expression. Our -3 stays in front as the coefficient, and then we have -11 plus 12 on the end. If we combine the like terms on the end, we get a positive 1 here. This gives us our equation in vertex form. And finally, for the vertex, we have an h value of positive 2 and a k value of positive 1. Setting the binomial equal to 0 gives us the x-coordinate of our vertex, and the k value or the y-coordinate of our vertex is just positive 1.